This video continues the discussion in section 5.3 of hypothesis testing, this time talking about the distinction between one and two-tailed tests. So a one and a two-tailed test are also sometimes called one and two-sided hypothesis tests. When we're interested in a two-sided hypothesis test, it means that we're interested in whether P is either above or below the null hypothesized value P sub 0. And in that case, we write our alternative hypothesis as P is not equal to P sub 0. And this is the type of test that we did in our example looking at the Facebook users in the first video for this section. Sometimes, though, we might only be interested in a difference from the null hypothesis in one direction. In a one-sided hypothesis test, we're interested in the population proportion P differing from the null value, P sub 0, in one particular direction and not interested if it differs in the other. And whether we're interested in a one-sided or a two-sided test is going to depend on how the research question is formulated. The example we've looked at before was looking at the survey of 850 American Facebook users. Among those surveyed, 60.8% believe that social media companies should be required by law to protect their users from disinformation. We did a hypothesis test that answered the question, do these data provide convincing evidence that the proportion of all American Facebook users who believe this differs from 50%? Because we had a differs from 50% in our research question, our alternative hypothesis was that P differs from 50%. And this is what we call a two-sided or two-tailed alternative hypothesis. We used the sample data to calculate the test statistic, which told us that the sample proportion was 6.3 standard errors away from the null hypothesis. When we wanted to find the p-value, we used the standard normal z distribution to find the area in the tails beyond 6.30 and beyond negative 6.30 in the standard normal distribution. Those two areas together were the p-value. We found the area in one tail was about 0.0000000000015. We multiplied that by 2 to get the p-value of 0.00000000003. Right? And that was our p-value. And our decision, because the p-value was very small, we rejected the null hypothesis. Let's look at the same example, but suppose this time we want to decide, do the data provide convincing evidence that the proportion of all American Facebook users who believe the statement is more than 50%? Now we're only interested in if it's more than half. We're not interested if it's less than half. And so our null hypothesis will still be that P is equal to 0.50. But now our alternative, what we're seeking evidence to support, is that the proportion P is more than half. So we've got this more than statement in our alternative hypothesis, and this is a one-sided test, also sometimes called a right-tailed test, because we're only seeking things that support a greater than statement. Now, if we use the sample data to calculate the test statistic, we're going to get the same test statistic because our sample proportion of 0.608 is still 6.30 standard errors away from the null hypothesis. But now when we want to find the p-value, remember the p-value is the chance that I'd see something as many standard errors from the null hypothesis as my actual sample statistic in a direction that supports the alternative hypothesis. So now values that are small below are not going to support the null hypothesis, the alternative hypothesis, but values that are high are the only ones that are supporting a more than type of alternative hypothesis. So I'm going to use the area only in this right tail above my standardized test statistic, Z. And that area there is going to be my p-value, which is 0.0000000000015. So my p-value is only half as big in this situation. Still, it's very small, so the decision I would make in this case would still be to reject the null hypothesis. So to summarize, when we're looking at one- and two-sided hypothesis tests, if there's only value in detecting that the population parameter is less than the hypothesized value, then we write our alternative as being the parameter p is less than the hypothesized value p sub 0. In this case, we find the p-value by using the area under the standard normal distribution that is to the left of the test statistic. And for that reason, this is called a left-tailed test. If there's only value in detecting the population parameter being greater than the null hypothesized value, p sub 0, then we write our alternative hypothesis that p is greater than p sub 0. In this case, the p-value is the area to the right of the test statistic, because that is the area that is more supporting the alternative hypothesis. However, two-sided tests are usually more appropriate, as it's usually helpful to be able to detect if the data go clearly in either direction from the null hypothesis. When we're doing these two-sided tests, we find the p-value by finding the area in both tails that are farther from zero than the test statistic. In any case, it's important to always choose the hypotheses that we're going to test based on the research question and before we collect the data. Failure to do so can make it so that you artificially lower your p-value and overstate how strong the evidence is in support of your alternative hypothesis. Thanks. Have a good day.